Welcome, Hornets. Today I am doing a review in preparation for the quiz that is happening on September 3rd, 2020. So we're going to start off by just taking a look at basic questions that are going to be on the quiz. And these are similar to the review that I gave in class. But since the worksheet does not have any detailed work, I figured I would go through it with you and provide you a video of how. So we're going to start off with our first problem, and that is locating the solution to the problem e of x times e to the power of 4x minus 1 equaling 7. And the way I told you to do this problem is to start with your equations on the left and separate it from the one on the right. You are to put these into your graphing calculator and use your calculator in order to find the intersection. So when you're doing this, let's just remind ourselves, we're going to start with an x. E is found by second divided by. Right above the division is the house, that top of the roof. It's called the caret. It gives us to the power of. We put 4x. We move the arrow over and we go minus 1. Go to y2 and put in 7 and follow it with zoom 6. You should see an exponential curve and a horizontal line. You are looking for the intersection between the two. Now, in order to find an intersection, you're going to be using your calculator and going through second trace. You'll notice that 5 is the intersection. By hitting 5, you will immediately go to the first curve. Hit enter, which will take you to the second curve. Hit enter, and it says, "Are you sure?" We hit enter to say yes. We are then given our solution, and as we saw in the in the worksheet, the solution is 0.6338, and that was how it was found. So please be aware, you are to use your calculator on the Quizle tomorrow. Make sure you have it so that you can do that. The next question was asking you to find the arc cosecant of 3.461. Now, the whole idea here, Hornets, is being able to remind yourself how to solve. Now, one thing you need to remind yourself is that our calculator will only work with sine, cosine, and tangent. So we have to work with the reciprocal function, arc sine. But because we took the reciprocal of the function outside, we must take the reciprocal of the piece inside. We can now plug this into our calculator. Let's start off by making sure that you are in radian mode. If you're not in radian mode, you will get this wrong. Send quit. Second, sine is how we find our arc sine. Put in 1 divided by 3.6, and I believe that's 461. Close parenthesis. Then all you need to do is hit enter. So you'll notice there's only one solution here. That's because we're talking about an arc. There would be two solutions if I put sine of theta equals 1 over 3.461. So there's only one solution here, and it's using your calculator to find it. The next problem that we had in that worksheet was trying to find the algebraic expression for the sine of arc cotangent of 1 over x. Now I can put anything here. I put 1 over x on the worksheet. That was very similar to what we did in class. The whole idea is cotangent is positive in the first quadrant. So I create a reference triangle in the first quadrant with theta being here. Cotangent is the adjacent over the opposite. So our adjacent side is 1, our opposite side is x. In order to find that missing side, we have to use the Pythagorean theorem. X squared plus 1 squared equals hypotenuse squared. This tells us that the hypotenuse is x squared plus 1, or 1 plus x squared. Our goal is to find the sine ratio for that theta. And the sine of theta is the opposite over the hypotenuse, which is x over the square root of x squared plus 1. That's what you're looking for. Okay? All right, the next question is a domain question, and it is asking you to identify the domain for f of x equals 2 natural log 3x plus 1. Now, the whole idea here is that natural logs, just like all logs, have asymptotes, and we can never reach the asymptote except abstractly in a mathematical sense. So if I say, can you physically reach it? No, we physically cannot reach it. Can we mentally conceive of what's happening? Yes. So mentally, we know that at infinity, we will reach that asymptote. This question is asking for where is that asymptote and what are the x values that we can use that will not give us an error. It's going to happen right in here. We're going to say that 3x plus 1 is always greater than 0. Everything that we have, notice inside of that natural log, that is the result of an e to a power. And e is a whole number, is a real number. It is irrational, but it's positive. And if you're going to take a part of a positive thing, you will have something positive. And therefore, 3x plus 1 has to be greater than 0. So we now solve for x, and we find that x is greater than negative 1/3. This now constitutes my domain. You can write it as the inequality that you see here, or you can use the interval notation. Calculus uses the interval notation, and so I would expect you to look for that answer. In the next question for this, we're looking at trying to construct a composite. We are told that f of x is equal to x cubed, and we are told that g of x is equal to 2x plus 1. There are two ways in which we can do this. We could find f of g of x, or we could find g of f of x. Both of these are composites. So let's just take a quick peek and see how the first one is going to go. In order to do this, we're going to take the x and we're going to replace it with parentheses and follow it with the cubed. We then put the 2x plus 1 inside. The second one works in the opposite situation, or the reverse, where instead of the x, we put x cubed plus 1. Notice that we like that second one a lot better than the first, as that one would give us 2x cubed. This one requires us to FOIL and work with Pascal's triangle or the binomial expansion theorem. Now, foiling, yes, you can do that, but you need to be careful because if you FOIL, you might make a mistake. So you need to double check your work. If you were using Pascal's triangle, we know that our coefficients are 1, 3, 3, 1. Let me write them down the page so that you can see what's happening. There is a pattern. So we have 1, 3, 3, 1. We're starting off with 2x, and this is to the third, with our 1 to the 0, followed by 2x squared, 1 squared. Whoops. That should be a 1 to the first, followed by 2x to the first, 1 squared, and finish with 2x to the 0 and 1 cubed. Notice how the 2x, the first term, starts off at a power of 3 and goes down to 0, and the 1, the second term, starts at 0 and goes down to 3, or goes up to 3. So we end up with 8x cubed here. We end up with 12x squared. We end up with 6x and 1. We then put this together as 8x cubed plus 12x squared plus 6x plus 1. And that's the answer we're seeking. We're now going to be taking a look at logarithmic condense and expand. When we are condensing, we are taking a multiple log, in this case, for log base b of m, and we're subtracting 2 log base b of n. Now, in order to condense, we're using the 3 rules that says a log of c is log c to the a power. This power moves in front. We're then going to use the second rule that says log of a plus log of b is the log of a times b. Notice that this sum is represented as a product. So using these 2 rules, we're going to start off with log base b of m to the 4th minus, and I'm going to make that a plus, log base b of n to the minus 2. Notice I took the minus as well as the 2, and this gives me the fraction. So when I now do my sum, log base b of m to the 4th n to the minus 2nd, I'm going to take one last step, and I'm going to make that fraction, m to the 4th over n squared. And that's my answer. Notice how I've taken a multiple logarithmic statement, as we had at the beginning, and it is converted into a single log statement. That's what condensing does. Expanding is going to now follow the reverse process. So if I take log base b of the 4th root of 3x squared y cubed, notice that all of these have the 1/4 power. So I'm going to take that 1/4 and I'm going to move it out to the front. Notice that they are all separated by a product. So I have 1/4 out in front, and I'm now going to expand it into the 3 terms. Log base b of 3 plus log base b of x squared plus log base b of y cubed. The last step is to move the power in front. So 1/4 log base b of 3 plus 2 log base b of x plus 3 log base b of y. Now notice if I had had a fraction, that fraction would have first become a negative exponent. I would have then separated them into the sum and then moved the negative exponent in front. This is our answer that we're looking at right here. The only thing that they could do next is to distribute the 1/4, and that is a possibility. Thank you, Hornets. I will do part 2 in just a moment, and we will finish the numbers 9 through 12 in the second video. Thank you very much.